Hey, my name is Stephen, and today I'll be reviewing Lab 2 called Lines of Charge. This lab is basically going through Lab 1 again, but this time we're going to be making a different assumption. So yeah, we're going to be looking at how charges interact with each other in the real world, and we're going to be using Coulomb's law again. But the assumption that we're going to be using now is that we're no longer going to be looking at the pieces of tape as a single point charge. Now we're going to be looking at the tape as multiple particles making multiple electric fields. And we're going to be basically summing all those electric fields to try to figure out the net charge of our pieces of tape. So yeah, the concepts that we're going to be using again is Newton's second law and Coulomb's law. So here's a quick summary of what I've done for Lab 1. Through the experiment, I concluded that the U-tape had to be positive due to it being attracted to negative and neutral objects, but being repelled against its own self. And later into the lab, we were given a situation where one piece of tape was causing another piece of tape to rise a certain height. So we basically had to find the charge of either of the tapes. So based on my observation, there was going to be a net acceleration of 0. So that's why I was able to use Newton's second law to set the force of gravity equal to the electric force. And basically, when I found the force of gravity, I could use Coulomb's law and basically rearrange everything to find a value for Q, which I have done to be equal to around 7.17 e to the negative 8th Coulomb. For the coding section, I had to make a model of that situation happening with the two tapes. And as you can see, the green arrow represents the electric force, and the orange arrow represents the force of gravity. And again, I had to calculate the charge of each tape, which I got around to be 7.17 e to the negative 8th coulombs. So this is great and all, but we have to realize that this isn't an accurate model as to what's actually going on between the two tapes. Here in the model, I represented each piece of tape as a single particle with only one electric field going on. But in reality, we know a piece of tape has so many particles with so many electric fields going on. So that's what we're doing for Lab 2, is that we have multiple particles making up multiple electric fields. So the objective of this lab is to basically try to guess the value or the charge of each tape. And we're basically looking at the results to see if the electric force does equal the force of gravity. And to summarize my process of doing this, I basically chose a number of particles to use for my model, and then calculated the electric force for each and every particle, and summed that up to make up our net electric force. So for my case, I used a Q value of 1.16 e to the negative 7 coulombs and used 1,000 particles for my model, which is why you can't really see the particles, maybe the blue ones, but yeah, the red ones, they're completely gone. But it did get a great result with the electric force equaling exactly to the force of gravity, which was awesome. Here I had to make some assumptions, like air resistance was a part of this model, and that each tape had the same net charge. So isn't this great? We got a value for Q. I'm feeling pretty good about myself. But at the same time, I mean, didn't I just waste my time? I mean, we could have just used the results from Lab 1, right? And just call it a day. Well, here we're trying to be a little bit more realistic by using multiple particles. Of course, here I only use 1,000, and I'm sure there's a lot more than 1,000 particles on a piece of tape. But I don't think this course is worthy of blowing up my laptop for. So yeah, 1,000 pretty good. But yeah, with using multiple particles, of course, we're going to get a drastically different answer for our net charge. Here I got 1.16 e to negative 7 coulombs. In Lab 1, I got around 7.1 e to negative 8 coulombs. So there is a big difference when we represent our tapes in a different way.